Hi Honors Pre-Calc, we're going to do a virtual Boardwork assignment, and I'm calling it this because it's just for practice and it won't be graded. So these are the 4 problems I want you to follow along with. I'm going to walk through a few of them. If you feel like you just want to see if you did the problems right and you don't really need to be guided, feel free to kind of fast forward through just to see how you did. Again, you don't need to upload anything for today. This is just for your own practice. Okay, so we're asked to solve the first 3 here, not on any particular interval. Number 15 is on the interval from 0 to 2 pi. It is good if you have your unit circle with you right now so you can reference it. Okay, we want to get cosine of x by itself. So in order to do that, we'll have to subtract 1 from both sides and then divide by 4. When we do that, we'll have cosine squared of x. Please note that you want to have the squared here before the x because the x is not squared, the cosine is. In order to get cosine by itself, we have to undo the squared by taking the square root of both sides. When we do that, we need a plus or minus out in front. And remember, when you take the square root of a fraction, you just take the square root of the top and the square root of the bottom. So we'll get plus or minus 1/2, and that's what the cosine of x equals. Now we're not asked to find just cosine of x, we're asked to find what is x. So we need to use our unit circle to figure out where is the cosine positive 1/2 and then where is the cosine negative 1/2. Remember, cosine is your x value for any angle on the unit circle. And we can see that the cosine is positive or negative 1/2 in the pi over 3 family. So we're going to have 4 answers, all of the over 3s. So our answers are going to be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, the period of cosine is 2 pi, meaning it takes 2 pi radians for one cosine cycle to be completed. Therefore, we have to add on 2k pi. Your book uses n. It doesn't really matter what variable you use. In this case, I've just been using k. I think that's what I was taught. So k is just an integer. That means that because we're not restricted to just one time around the unit circle from 0 to 2 pi, every time we hit this spot on the unit circle, pi over 3, no matter how many times we circle it, the cosine will be 1/2 there. So this is always an answer plus however many full revolutions around the unit circle we make. So we're going to write that for every single one. And yes, we do have to say that k is an integer, but instead of writing that 4 different times, I'm just going to write that at the top. K is an integer. If you watched the last video, you also saw an alternate way of writing that, is that k is an element of the integer set. And the integer set is a boldface z, which we make bold by doubling the lines in the middle part of the z. So you can either write out in words that k is an integer, or you can use mathematical notation to write it out. Either way, you don't have to write it after every single one. So here's our answer. And we basically got that by doing algebra to solve for cosine. Then we had to use our unit circle and use trig to figure out where is the cosine positive or negative 1/2. It's at 4 spots on the unit circle. And since the period of cosine is 2 pi, we had to add 2k pi where k is an integer to all 4 of our answers. This next problem involves tangent, and it's not squared, so we don't have to do any square rooting. Instead, let's just get all of our tan x's by themselves on one side and get all of our constants on the other side. So I'm going to subtract 3 tan x from both sides. So we're left with just 1 tan x here. And then at the same time, I'm going to add 7 to both sides. So we'll have tan x equals 1. I'm just doing that to save some space. All right, so we're done with the algebra part of our problem. Now we need to do the trig part. We want to know where is the tangent just 1. This is different from the other problem where we had a plus or minus. And so we had like 4 spots on the unit circle that worked. In this case, we don't have a plus or minus, so we're just going to have like probably 2 spots on the unit circle that work. But it is tangent. So let's take a look at where the tangent is 1. Remember, tan is sine over cosine, or y over x. So for tangent to equal 1, sine and cosine have to be the same. That happens at pi over 4 and at 5 pi over 4. Okay, now the period of tangent, unlike sine and cosine, the period of tangent is only pi. That means that tangent repeats itself after pi radians instead of taking 2 pi radians like sine and cosine. Therefore, if you think about starting at pi over 4 on our unit circle, I'll sketch it out here. Pi over 4 is right here in the first quadrant. If we add an entire pi, or 180 degrees, we'll get over to 5 pi over 4. And then if we add another pi, we'll be back to where we started, and so on. The cycle will continue. So because the period of tangent is pi, when we add k pi instead of 2k pi, then we actually include this answer up here if k was 1. Pi over 4 plus 1 pi gets us to 5 pi over 4. So really, we only need this to be our answer because it includes 5 pi over 4. If you wrote both of them out, that's fine too. So again, this is a sufficient answer. It's actually the best one. But you could also include both of these and still be fine. But technically, this encompasses this. So this is really all you need. All right, this next problem has a squared in it, so it's very similar to number 3. I am going to challenge you to pause the video, try it on your own, and then play to check your answer. Okay, just wanted to give a quick hint. I didn't give the answer just yet. We're looking for where the cotangent is plus or minus root 3. You can also, if you want to use the reciprocal of cotangent, if you're more comfortable with tangent, it'd be 1 over that, plus or minus, or if you want to write it like this. I also included a unit circle, which I'll make a little larger. So that's what we're looking for. Remember, the period of tangent and cotangent also is just pi. Okay, here are the solutions. So we're looking for, I like to think of tangent more, just personally. So we're looking for where the tangent is positive or negative root 3 over 3. So that means when we take y over x, we need to get the 1 up top and the root 3 down below. So that's basically, that's basically at this point right here, pi over 6. It'd be 1/2 over root 3 over 2, right, which would give us this for tangent. So it's the pi over 6 family is what we're looking at, because we want to include the positives and negatives. So it's our pi over 6 family. Now we only need 2 answers because the period of cotangent or tangent is pi. So if we start at pi over 6, every time we add pi, we'll get to 7 pi over 6. Then we add pi again. We'll get back to where we started. So this right here, pi over 6 plus k pi, where k is an integer, includes pi over 6, obviously, but it includes 7 pi over 6 because we're adding a pi. So it includes these 2 spots. Whereas 5 pi over 6, if we start there and we add an entire pi, half the circle, we're at 11 pi over 6. So these 2 answers here with the plus k pi's will hit all 4 of the pi over 6 family that we want, plus however many times we decide to go around the unit circle. Okay, this last one here for our virtual board work is going to involve some factoring. We know that because we have two trig functions being multiplied here. So, and in this case, we only want to answer on the unit circle 0 to 2 pi. So we don't need to have the plus like k or plus 2k pi or anything there because we're only going around the unit circle once, not multiple times. All right, so let's go through this one. If you feel confident, pause and just see how you do. All right, we're going to get this to 0, so I'm going to subtract what's on the right-hand side. So we're left with 4 cotangent x minus cotan x sine squared x equals 0. So I just subtracted this term from both sides. Okay, now we can factor out the greatest common factor between the two terms, which is cotangent of x. So we're left with 4 minus sine squared of x. From here, we want to set each factor to 0. So we're going to set cotangent of x equal to 0, and then we'll solve that. Then we're going to set 4 minus sine squared of x equal to 0 and solve that. Okay, this one doesn't necessarily need solving. We're done with the algebraic part. This one does need solving. We'll get there. Let's figure out where is the cotangent 0. So on your unit circle, remember cotangent is x over y. So it's cosine over sine. So we want to know where is our x 0. Our x is 0 at pi over 2 and 3 pi over 2. So that's where the cotangent is 0 on our unit circle. So these are definitely two answers that we're going to have. Let's see if we'll get any answers from this other factor here that we have to set to 0. So to solve, I'm going to add sine squared to both sides. You could have also subtracted 4, but I just want to keep it positive. We'll take the square root of both sides. Okay, where is the sign 2 or negative 2? Nowhere. So we do not have any answers provided from this factor because the sign cannot be less than -1 or greater than +1. Therefore, the sign can never equal plus or minus 2. These are our two solutions on the interval from 0 to 2 pi. All right, happy virtual board work day. You will have a quiz review being released tomorrow, which I suggest that you work through. Also, if you have questions on any of this stuff, please find me on Zoom daily from 9 to 10 a.m. The link is in my Blackbot announcement every single day. And it's been really fun talking and working through math with some of you that have gotten on there. So thank you. If you haven't logged on yet to ask any questions, feel free. I'm always available from 9 to 10 a.m. And I will talk to you guys soon. Take care.